All right, you guys, welcome to this page of the notes. And again, what we're doing is we're going to work our way through a couple more example problems using the factor theorem to find all of the factors of a polynomial and thereby find the zeros of that polynomial. So let's jump right into this. I have given you a polynomial. Please notice it is a third-degree polynomial, which means when I get done, I had better have 3 zeros. According to the fundamental theorem of algebra, I already know how many solutions I should get. I should have 3 when I get done. If I don't, I made a mistake somewhere. I've also given you x minus 5, and I've asked you to determine whether that is a factor of this polynomial. That means synthetic division. So here we go. We're going to set up our synthetic division first. 3, 2, 1, 0. I'm not missing anybody. I don't need any placeholders. And I know that I'm going to do synthetic division with a positive 5. How do I know that? Set this guy equal to 0 and solve. So the 5 goes inside the box, and it's going to be a 1, a negative 7, a 7, and a 15. Bring down that first term and multiply. That's going to be a 5, which means I get a negative 2. That's going to be a minus 10, which gives me negative 3. That's going to give me a negative 15. And look at that. I get a remainder of 0. What does that mean? That means that x minus 5 is a factor of the polynomial. So yes, x minus 5 is a factor. So now what I do is I rewrite, right? This polynomial is now equal to this binomial, this factor, x minus 5, and my reduced polynomial, which I get from the synthetic division. So I now have x minus 5, and my original polynomial was x cubed, so now it's going to be an x squared minus 2x minus 3, right? This guy right here is my reduced polynomial, which I get by doing the synthetic division, and the factor that you were given, x minus 5. Again, remember, if you were to distribute this out, right, multiply it all together, you would get right back to what you originally started with. Now what I need to do, right, to find the remaining factors is go back to section 5, run through that list of 7 factoring techniques that we gave you to go ahead and factor this trinomial. Actually, this one's really easy. It'll factor into 2 binomials. There's the easy bit. X times x gets me x squared. Then I need 2 numbers that multiply to a negative 3 and sum to a negative 2, which of course is going to be a minus 3 and a positive 1. I didn't have to do the slide and divide method because this leading coefficient was already 1, so there's no sliding, there's no dividing. These are my 3 factors. Again, if you were to set this equal to 0, the 0 product property will split them up and solve. X equals 5, x equals 3, and x equals minus 1. 1, 2, 3. We said at the beginning the degree was a third-degree polynomial. I already knew I should get 3 zeros, and that's exactly what I got. I got 3 zeros. What this tells me is that this polynomial will cross the x-axis at a positive 5, positive 3, and a negative 1. Guys, that is really good work. Well done. Awesome, awesome algebra. I got another one for you here. Let's try again. First, I need to determine if x minus 2 is a factor, which means I'm going to need to do synthetic division. 3, 2, 1, 0. Everybody's there. I don't need any placeholders, and I'm going to do synthetic division with a positive 2. Set this guy equal to 0 and solve. That's how I know it's a 2. So 2 goes inside the box. 1, negative 7, 4, and 12. And we do the synthetic division. Bring down the 1, 2, that's going to be a negative 5, that's going to give me a minus 10, which gives me a negative 6, that's going to give me a minus 12, and look at that, I get my remainder of 0, which tells me that yes, x minus 2 is a factor. What that means is that this polynomial is equal to x minus 2 multiplied by my reduced polynomial. Since it's a third degree polynomial, this will now be a second degree, so x squared minus 5x minus 6. Again, if you were to multiply this out, you get right back to what we started with, right? That original polynomial. But that's not what we're trying to do. We're trying to find the remaining factors. So we go back to section 5 of chapter 5, that list of 7 factoring techniques. We're going to use that to factor this guy out and get another general trinomial. This one's pretty easy as well. I don't need the slide and divide method because the leading coefficient is already 1. The easy bit. X times x gets you x squared. Slightly trickier, I need two numbers that multiply to a negative 6 and sum to a minus 5. Actually, it's not, yes, it is a little tricky. No, it's not that tricky. Negative 6 and a positive 1. Negative 6 times a positive 1 is a negative 6. Negative 6 plus positive 1 gets you the negative 5. So there we go. I've got my 3 factors, set it equal to 0, which allows me to use the zero product property. And once again, the fundamental theorem of algebra tells me since this is a third degree polynomial, I should have 3 zeros. 2, 6, negative 1 are what my algebra says. That's where my polynomial is going to cross my x-axis. Those are my zeros, and there's 3 of them. So the fundamental theorem of algebra checks out. I am confident that I did this one right. And guys, I cannot overemphasize, this is a really, really big deal. This factor theorem of algebra, to use the factor theorem as a method for finding the zeros of a polynomial, this is really, really big stuff. So good job on this. I'm really glad that you joined me for this set of videos. This factor theorem and remainder theorem is actually probably one of my favorite things in algebra. I just love the way that all of this ties together. Plus, here in this chapter, we get the fundamental theorem of algebra. And again, I asked that question, what does it mean to be fundamental? Just really, really important chapter when it comes to algebra. And this factor theorem is a really awesome theorem. You're doing a lot of great algebra here. So thank you again so much for joining me for this set of videos. And I'll see you guys next time.